The UK can switch from mild winters to sudden snowstorms overnight. This isn't random, it's due to a phenomenon called sudden stratospheric warming, SSW. This atmospheric event flips a switch, bringing Arctic air to the UK, affecting everything from commutes to supermarket prices. SSW disrupts the normal airflow, causing unpredictable weather patterns. We'll explore how SSW works, its impact, and how scientists predict these events. Let's dive into the science behind these winter surprises. Imagine for a moment that the atmosphere above us is like a giant multi-layered cake, each layer with its own unique flavor and purpose. This cake stretches from the ground all the way up to the edge of space, and each layer plays a crucial role in shaping the weather and climate we experience every day. The layer we call home is the troposphere. This is the lowest slice of the atmospheric cake, and it's where all the action happens. Clouds form, rain falls, winds blow, and storms brew. Every weather event you've ever experienced, from gentle breezes to raging hurricanes, takes place right here in the troposphere, which extends up to about 10 kilometers above the ground. But just above the troposphere lies another important layer, the stratosphere. This is where the famous ozone layer resides, acting as Earth's natural sunscreen by absorbing and blocking harmful ultraviolet rays from the sun. The stratosphere is generally calm and stable, and it stretches from about 10 to 50 kilometers above the surface. Most of the time, especially during the long, dark winter months over the North Pole, the stratosphere is bitterly cold. Temperatures can plunge to minus 80 degrees Celsius, or even lower, creating a frigid cap over the polar regions. This icy environment is a key part of the polar vortex, a swirling mass of cold air that circles the pole high above the ground. But sometimes, something extraordinary happens. In a matter of just a few days, the temperature in the stratosphere can skyrocket by as much as 50 degrees Celsius. This dramatic event is known as sudden stratospheric warming, or SSW for short. Imagine the temperature in your freezer suddenly jumping to that of a warm spring day. It's that extreme and that sudden. You might think this warming is caused by the sun, but that's not the case. Instead, it's the result of powerful energy and waves generated down in the troposphere, our weather layer, pushing their way upward. These waves, created by things like mountain ranges and strong weather systems, transfer energy into the stratosphere, setting off a chain reaction. When this energy reaches the stratosphere, it disrupts the usual flow of air, shaking up the polar vortex and sometimes even splitting it apart. The stratosphere, once calm and cold, becomes a turbulent zone of rapidly rising temperatures and swirling winds. This massive atmospheric shakeup can last for weeks, sending ripples throughout the entire atmosphere. Here's the twist: even though the stratosphere is warming up, this event often triggers a cascade of changes that lead to much colder weather down below, in the troposphere. The disruption above can weaken the polar vortex, allowing frigid Arctic air to spill southward into North America, Europe, and Asia. So, while the sky heats up, the ground can plunge into a deep freeze, bringing snowstorms and icy blasts to places that might not expect them. Sudden stratospheric warming events are a powerful reminder of just how interconnected our atmosphere truly is. What happens high above our heads can have dramatic effects on the weather we experience at the surface, sometimes weeks later. Scientists study these events closely, using satellites, weather balloons, and computer models to better understand the complex dance between atmospheric layers. In short, a heat wave in the sky can set the stage for a deep freeze on the ground. The next time you hear about a sudden cold snap or an unexpected snowstorm, remember, the answer might just be found high above, in the mysterious world of sudden stratospheric warming. The polar vortex is a swirling mass of cold air over the North Pole, contained by strong winds. This vortex is a crucial component of our planet's climate system, acting as a barrier that keeps the frigid Arctic air confined to the polar region. The strength and stability of the polar vortex are determined by the powerful winds that encircle it, creating a sort of atmospheric wall. When these winds are strong, the vortex remains stable, and the cold air stays put. However, this delicate balance can be disrupted by various atmospheric phenomena. Rossby waves from the troposphere can disrupt this vortex. These waves are large-scale meanders in high-altitude winds that are influenced by the Earth's rotation. They play a significant role in shaping weather patterns across the globe. When these waves become particularly pronounced, they can interfere with the polar vortex, causing it to become unstable. This interaction is a fascinating example of how interconnected our planet's atmospheric systems are, with changes in one area having far-reaching effects. These waves, generated by mountains or temperature differences, carry energy upwards. The energy transfer from the Earth's surface to the upper atmosphere is a complex process, influenced by various factors such as topography and temperature gradients. Mountains can act as barriers that redirect air currents, while temperature differences between land and sea can create pressure systems that drive these waves. As the energy moves upward, it can interact with the polar vortex, adding to the instability. When they hit the vortex, they can cause it to wobble or split. This wobbling or splitting of the vortex is a dramatic event that can have significant implications for weather patterns. A split vortex can lead to the formation of multiple smaller vortices, each with its own dynamics. This can result in unusual weather conditions, such as extreme cold spells in regions that are typically milder. The deformation of the vortex is a clear indication of the powerful forces at play in our atmosphere. This weakens the winds, allowing cold air to escape. As the polar vortex becomes unstable, the winds that normally contain the cold air weaken, creating pathways for the frigid Arctic air to spill southward. This can lead to sudden and severe cold snaps in areas far from the Arctic, affecting millions of people. The movement of cold air masses across continents is a striking reminder of the interconnectedness of our global climate system. The compressed air heats up, causing the sudden warming. This phenomenon, known as sudden stratospheric warming, occurs when the air in the stratosphere is compressed and rapidly heats up. This warming can further destabilize the polar vortex, exacerbating the effects of the initial disruption. The sudden increase in temperature in the stratosphere is a key factor in the breakdown of the vortex, leading to significant changes in weather patterns. The breakdown of the vortex sets the stage for weather changes far from the Arctic. As the polar vortex weakens, the jet stream, which is a fast-flowing air current that circles the globe, can shift its path. This shift can lead to unusual weather patterns, such as prolonged cold spells, heavy snowfall, or even unseasonably warm conditions in some areas. The impact of these changes can be felt across the world, highlighting the importance of understanding and monitoring the polar vortex and its interactions with other atmospheric systems. High above the Earth, in the stratosphere, a powerful circulation of cold air known as the polar vortex spins around the Arctic. This swirling mass acts like a barrier, keeping the coldest air locked far to the north, but sometimes this polar vortex can weaken, or even split apart, a process often triggered by a dramatic event called sudden stratospheric warming, or SSW. When this happens, the effects don't stay confined to the upper atmosphere. They ripple down, setting off a chain reaction that can reach all the way to your doorstep. One of the first things to change is the jet stream, a fast-flowing ribbon of air that snakes around the planet in the troposphere, just below the stratosphere. The jet stream acts as a boundary separating cold polar air from the milder air to the south. It's like a high-speed highway for weather systems, guiding storms and influencing temperatures across continents. Under normal conditions, the jet stream is relatively straight and strong, keeping the frigid Arctic air bottled up to the north and shielding places like the UK from extreme cold. But when an SSW disrupts the polar vortex, it sends shockwaves down to the jet stream, causing it to weaken and become wavy, meandering far north and south instead of following its usual path. These dramatic bends in the jet stream open the door for cold Arctic air to spill southward, reaching areas that are usually much milder like the UK and much of Europe. Suddenly, the weather can shift from mild and wet to bitterly cold and snowy in just a matter of days. At the same time, a blocking high-pressure system often forms over northern Europe. This acts like a wall, stopping the usual flow of weather from the Atlantic and reversing the typical wind patterns. Normally, the UK enjoys relatively mild westerly winds that bring in moist, temperate air from the Atlantic Ocean, keeping winters damp but not too cold. But with the high pressure block in place, those westerly winds are cut off. Instead, icy easterly winds sweep in from Siberia, carrying bone-chilling air across thousands of miles straight to Britain's shores. As this frigid air travels over the relatively warmer waters of the North Sea, it picks up moisture. When this moist cold air reaches the UK, it cools further and releases its moisture as heavy snowfall, blanketing towns and cities in white. So, a sudden stratospheric warming event, which begins high above the Earth in the stratosphere, can set off a cascade of atmospheric changes that ultimately bring a snowstorm right to your street, demonstrating just how interconnected our planet's weather systems truly are. In February 2018, the Beast from the East was a memorable SSW event. Scientists observed a major SSW disrupting the polar vortex. 2 weeks later, the jet stream buckled, and cold air swept across Europe. The UK faced one of its most significant snow events in years. Temperatures plummeted, and heavy snow blanketed the country. Major cities were paralyzed, with schools closed and flights cancelled. The Beast from the East showed how vulnerable we are to extreme cold. We can often predict SSW events, unlike sudden thunderstorms. Scientists monitor the polar vortex using weather balloons, satellites, and computer models. This gives us up to 2 weeks to prepare for potential impacts. Weather balloons measure atmospheric conditions, while satellites track the polar vortex. Computer models simulate the atmosphere, predicting SSW events. While prediction isn't perfect, it helps us prepare for cold snaps. Scientists are improving forecasts to better understand SSW impacts. Understanding SSW events impacts our daily lives, safety, and economy. A 2-week warning allows us to prepare for major cold snaps. Energy companies, transport authorities, and emergency services can plan ahead. This preparation prevents power outages and keeps transport routes open. Hospitals can prepare for weather-related incidents, and farmers can protect crops. This knowledge makes society more resilient to extreme weather. A major cold snap from an SSW event can be serious. Vulnerable people face life-threatening conditions, and the economic cost is huge. Transport paralysis leads to lost productivity and crop losses. The Beast from the East cost the UK economy around £1 billion per day. Isolation and stress increase during prolonged cold periods. However, communities often come together to help one another. These events highlight our vulnerabilities and the importance of community spirit. SSW events show the atmospheric connection from sky to street. Forecasting these events is a major achievement in meteorology. This knowledge empowers us to prepare and adapt to weather changes. As climate changes, understanding SSW events becomes more critical. Future weather science will improve forecasts and preparations. By understanding the science, we gain confidence and resilience. Next time winter surprises you, remember the journey from stratosphere to snow. It's a testament to the power of science and our ability to face the future.